So you had questions regarding the domain on these, and so there's kind of two things to know about that. One is if we have a root, whatever math is under that root, to figure out the domain, we can't have negatives under radicals. We can, but then they become imaginary numbers, and that's not a part of the domain. If you think about your square root function graph, right, it's that one that looks like this. None of the negative values are represented on the graph. We can only put in 0 or greater. So we want to go math under the radical, whatever it might be, is going to be greater than or equal to 0. The other thing to remember when solving a inequality is if you multiply or divide by a negative value, that flips the direction of the inequality. So for instance, if I had negative 2x is greater than 6, and I divide both sides of that by negative 2, by dividing, that flips the direction of the inequality, and this becomes x is less than negative 3. If you try that back in the original answer, that makes sense. If I try, and in terms of interval, or in terms of interval notation, not a graph, x is less than negative 3, so that'd be from negative infinity up to not including negative 3. If I put negative 4 in that original equation, negative 2 times negative 4 is 8, because of the double negative, which is indeed bigger than 6. If I tried to put 4 in this equation, I'd have negative 8 is greater than 6, not true. And so that's why when you divide by that negative, what you're doing is you're reversing, it's going to be the things that would make this greater than are the opposites, they're the negatives instead of the positives, essentially. I'm not saying that very well, but to kind of get back to the point, if you multiply or divide both sides by a negative value, you flip the inequality. And so I'm going to guess these first couple probably went okay. With this one, x minus 28 is greater than or equal to 0. You're just adding the 28 over, and x is greater than or equal to 28. And then you just have to kind of think about what that graph would look like. The x's are bigger than that, so we would have a bracket on the 28, whoops, with an actual 8 there, and then off to infinity. If you have any trouble graphing these, or writing the interval notation, think about the picture. So if this is 28, x is greater than 28, I always use the inequality as kind of a reminder which way that arrow is going. And if I picture that graph in my head, then I don't get things backwards. Where I think these are a little bit dicier is probably on the third one and the fifth one. So like the third one, for instance, we'd have negative 2x. Oh, it's almost this exact problem that I did over here. That's kind of funny. Plus 6 is greater than or equal to 0. So that's my plan for finding domain on these every time, and that is have to kind of follow the math. So I'll subtract that 6 over. Negative 2x is greater than or equal to negative 6. And then dividing both sides by negative 2, and that dividing is what triggers the flip of the inequality. So this would be x's that are less than or equal to positive 3 should make this true. And so if I put in 1 just to try it out, 1 right there, negative 2 plus 6 is indeed greater than 0. If I try 4, which isn't in this domain, right, because this would be from negative infinity to 3 with a bracket. If I tried 4, something outside of that, I'd have negative 8 plus 6 is negative 2, not greater than 0. That wouldn't make any sense. But I bet it's that dividing by a negative where you might have had some challenges. Let me know if you still have questions.